Today's lesson is how to divide greater numbers, meaning numbers that have more digits in them. Let's start with a real-life problem. So we know that there are lots of different jobs out there, and one job that people have, and even had in colonial times, would be a chandler, which is a candle maker. So let's say that a certain candle maker has 638 candles that she needs to pack. She needs to pack them into boxes, and the boxes that she has each fits 18 candles. So that means that we have 638 candles, and we're packing them into boxes or groups of 18. Now here's the question. Write it down very carefully along with these notes. How many boxes can be completely filled? Completely filled. Not partially filled, not a little bit filled, not almost filled, but completely filled with 18 candles in them. All right, well, it looks like we've got a division problem. 638 candles divided into groups of 18. These are not very friendly numbers, so the first thing that we need to do is estimate. 18 is not a very friendly number, but it's very close to a friendly number, 20. Now, usually when we have a divisor that's one digit, we keep it the same and we change our Big Daddy dividend to match and be compatible with it. But with two-digit divisors, we can go ahead and make those friendly and now make this match. So 20, and now I'm looking at 638, and I want to find something that's going to be compatible with 20 or with 2. If I want this to be a 30-second mental math estimation problem, I'm thinking 600 divided by 20. Okay, so I've got my digits. 6 divided by 2, or 2 times what is 6? That would be 3. Now I need to deal with the zeros. I know that our little trick for this is canceling out any zeros that we have here in the divisor with any zeros that match, so 1 and 1 for divisor and dividend. I'm left with one more zero. So that means I need one more zero in my estimate as well. So 600 divided by 20 is 30. I'll circle that estimate, and now we're ready to move on and actually solve. S for solve. Here we go. Setting up the problem using this division symbol. So 638 divided by 18, and we're going to use the traditional or standard algorithm. This is the way that I was taught growing up and your parents were taught growing up, so they'll be very happy that you're doing math that makes sense to them for once. All right, so what we need to do is we need to think, what was our estimate? Well, our estimate was 30, or about 3/10. So let's use that estimate to figure out where to place our first digit. If it was 30, or 3/10, that's in the tens place. And sounds like maybe 3 should be our number here. So that is the find step in our father, mother, sister, brother trick for remembering the steps of long division. So we found something that we can multiply by 18 that we are hoping gets us less than or equal to 63. We can't do something that's going to get us more than 63, because then when we multiply and go to subtract, we're going into negative land, and we are not going to do that. So we might need to do some side multiplication. We are now on the multiply step, so I'll go ahead and do this multiplication off to the side in red. So 18 times 3. Well, 3 times 8 is 24, and 3 times 10 is 30. Add those partial products together and get 54. Excellent. I can write that over in my problem. It is less than 63. And now I'm moving on to subtract. Subtract 54 from 63, and we get 9. Now, we check and make sure, could I have taken any more groups of 18 out? Because if I could, I'm in trouble and I need to increase that by 1. Maybe I could have taken out 4 groups instead of just 3. Well, let's take a look at what's left. Only 9 candles are left. So, and really it's not a 9, it's a 90 because it's in that tens place. But if we're just looking at the digits, it's a 9. Nope, couldn't take out any more. So we're safe. So now we go on to the bring down step. And we're going to bring down the next digit, which is an 8. So now we have 98. Okay, well, we need to go back to Father, find. We need to find something here that we can multiply by 18 that gets us either less than or equal to 98. Gosh, that's not very friendly, multiplying by 18. But maybe if we could just estimate, that might help us out. Maybe we can think, instead of 18 times what can get me 98, unfriendly numbers, we could estimate for this. 18 is pretty close to 20. 98 is pretty close to 100. So I could think, well, 20 times what number gets me to 100? Well, 20 times 5 gets me to 100. So maybe I've found a 5 that could work in my problem. Let's try it. We'll put that 5 up there, and now it's time to multiply. 5 times 18. So we'll need to do some side multiplication. I'm running out of room on my board. I don't want you to erase anything though, because sometimes you'll end up going back and using what you've already written again in the problem, especially if it's a really long one. So don't erase, even though I'm going to. You just go ahead and write it off to the side. 18 times 5. Now this is where all of your other multiplication strategies and different models can come in handy. Last time I did partial products. That was nice. I could do traditional algorithm. I could even say, hey, I know what 18 times 3 is, and I can also double 18 in my head to figure out what 18 times 2 is. Put those together, I've got 18 times 5. You might do a ratio table. Whatever you do, you should end up with 90. So now we'll put the 90 down, and it's time to subtract. We have 8 left. We go on to our next step. Bring down. There's nothing else to bring down. So that means we have 35, remainder 8, or 35 and 8/18. Well, those are both divisible by 2. So if we reduce the fraction by dividing the numerator and the denominator in half, that would be 4/9. So 35 and 4/9. But wait, we're not done. We need to do our check step. So we need to check back with our estimate. Were we close? Look at what your estimate is. 30. Yeah, pretty close. But we can also check for sure and check with the inverse operation of division. The opposite or inverse of division is multiplication. So let's check. Let's take our whole number, 35, and let's multiply it by 18, which was our divisor. 35 times 18. Why don't you go ahead and pick a strategy for solving that, the right tool for the right job. Press pause and solve that now. And I got 630. Hopefully you did too. Now, 630 is not our dividend. Our Big Daddy dividend was 638. Well, let's look at our remainder. Our remainder right here was 4/9. That's because we reduced our fraction. So we're not talking about groups of 18 anymore. We're talking about groups of 9. Well, that's not going to work for interpreting our remainder for this problem. So what we need to do is we need to go back and we need to look at what the remainder was at the bottom of that long division problem. It was an 8. That means that we need to think remainder 8, we need to add that in. So 630 plus 8 equals 638, our dividend. Good. Check is all done. But have we answered the question yet? If you look back in your notes, you'll see that the question was how many boxes will be completely filled. So what does that mean for our remainder? We know we estimated, solved, and we checked with multiplication, so we know we solved the problem right. But now we actually need to answer the question that's being asked. How many boxes are totally full? Well, that would just be our whole number. 35 boxes would be completely full. The leftover 8 candles aren't enough to fill another box. So we don't have 36 boxes. We wouldn't say that we have 35 and 4/9 boxes are completely filled because 4/9 of a box is not a full box. So just 35 boxes are completely filled. Sometimes problems can be a little bit trickier, especially if we end up having the digit 0 in the quotient or the answer. So let's take a look at this problem. 7,854 divided by 74. Yikes. Okay, before you go deer in headlights, you can do this. Let's estimate first. I decided that changing the 74 to 80 would be a good move because my dividend is really close to 8,000, and that's nice and compatible with the 80. And I get 100. So my answer should be close to 100. This also shows me that I don't have anything in the thousands place. So when I go to solve this problem, my first digit is most likely going to be in the hundreds place. And it's most likely going to be a 1. So this is my solve section. I've set up my division problem. And I've also reminded myself of the father, mother, sister, brother system of find, multiply, subtract, and bring down. So let's figure this out. My estimate told me that it would most likely be a 1 in the hundreds place, and we can see if that makes sense. Yeah, if I find something that's going to work, 1 times 74 is 74. Now we know that that's really a 100 and it's really a 7,400, but if we're just looking at the digits, that works. We now subtract. We have 4 left. We'll bring down the 5. Now 45. Can I take any groups of 74 out of 45? No, 45 is too little and 74 is too great. So that means I can take 0 groups of 74 out of the 45. Now, you can still go through the father, mother, sister, brother. We can multiply. 0 times 74 is 0. We can still subtract. And lo and behold, we still have 45. So you can still go through that step. Or if you know that you're placing a 0 in the quotient, you can go ahead and skip some steps and just bring down the next digit. But it's always safe to go through the steps. We now have 454. I need to find a number that's going to get 74 times some number that's less than or equal to 454. Wow, that's really unfriendly. So let's think here. So instead of thinking about those unfriendly numbers, let's change them. 74 times what is 454? Well, let's change the 74 into a 70. That's pretty close. And I know that 7 would be compatible with 42 because 7 times 6 is 42. It's written on my teacher's shoe. So that means that n would be 6 in that case. I know that's just an estimate. I know it might not be exact, but it should be pretty close, and it's worth plugging in and trying. So we plugged in the 6 there. Now, we've found we need to multiply 6 groups of 74. Go ahead and set up that multiplication problem however you would like. Figure it out, press pause now. I used the distributive property with parentheses to solve this one, broke the 74 into 70 plus 4, and then used parentheses to distribute, and I got 444. Hopefully that's what you got, no matter what method you used to multiply 6 times 74. Now we go on to subtract. We have 10 left. We go on to bring down. Oh, nothing else to bring down. Okay. Well, let's see. Could I take out any more groups of 74? I only have 10 left. Nope. Looks like our remainder is 10, or 10 74ths. Just one step left, and that is check. First, check your estimate. Are we pretty close? Yeah, we're really close. Our estimate was 100. Now, to double check and check to be exact, we can use the inverse, multiplication. We're going to take our whole number, 106, and multiply it by our divisor, 74. We'll deal with that fraction or the remainder later on. Go ahead and solve this multiplication problem with any strategy that you think is going to be efficient for these numbers. I encourage you to try the traditional algorithm of multiplication because we've got a lot of digits here that's most likely going to be pretty efficient. Press pause now. No matter what method you used, you should have gotten 7,844. But wait, that's not our dividend. That's okay though, because our remainder was 10. So if we tack on that remainder, we should get our dividend. And we do. Check. So our answer is 106 and 10 74ths. See if you can reduce that fraction for some bonus points. And that's it for the lesson for today.